Dear students, happy Raksha Bandhan. Due to Raksha Bandhan, we could not place any videos. Today, we are in continuation with the numerical, which is based on the electrostatic. Now, the question which is based on the electrostatics, definitely on Coulomb's law, and we know very well about the Coulomb's law. The force between two charges will be directly proportional to product of their charges and inversely proportional to the square of the distance between them. Finally, we get a relation between two charges, that is F is equal to K times Q, 1 into Q2 upon R square. So this which we are going to apply here. Now a simple point charges of 3 microcoulomb and minus 2 microcoulomb placed on x-axis at x equal to 4 meter and x equal to 8 meter respectively. Find the magnitude of the charge that must be placed at x equal to minus 4 meter so that the charge kept at the origin experience no electrostatic force. Now total charge which is placed on the x-axis. So we know that if we go for simply for calculating the electrostatic force, we can have here Q upon R square, where Q is the charge and small q is another charge and R is the distance between their separation. Now here there will be force because of this, there will be force on this Q because of this charge, and this charge will also give the force. So if we go through these forces, now see here, this is a repulsive force which will be acting in this direction. This is also a repulsive force which will be acting in this direction, and this is a force which is attracting. Means these two forces will be in the same direction. It is a force of attraction, it is a force of repulsion, and one force is here. And the sum of these two forces, all these three forces will be equal to 0, because at this it must have 0 force. On this point, so we can say it is point P, it experienced 0 force. So we can go with the law. If we take this Q, K times Q into Q upon this distance which we can take 4 square, another force which is acting, that we can take it as a minus because it is acting in this direction. It is K times Q into 3 microcoulomb divided by R square, that is 4 square. I am taking this charge here, which is these two forces. One is attracting, it is attracting this. So it is of Q, K is here, 2 into 10 raised to the power minus 6 upon 8 square. Now we go through this KQ, here KQ, and we can take it equal to 0. So K times Q, which is, we can write it like this, 2 into 10 raised to the power minus 6 upon 64, because it is Q upon 16, small q, and it is 3 into 10 raised to the power minus 6 upon 16. Now, final simple calculation, 2 into 10 raised to the power minus 6 plus q, it will be 4 times q, it is also 12 into 10 raised to the power minus 6, which is equal to 0. So 4q, which is equal to minus 10 into 10 raised to the power minus 6, which is equal to 0. So we can have Q is equal to 10 into 10 raised to the power minus 6 divided by 4, and it will give 2.5 into 10 raised to the power minus 6 coulomb. 2.5 microcoulomb is the correct answer. So if a charge of 2.5 microcoulomb is placed here, it will experience no force. Because of this, and because of this, the net resultant force will be 0 at this point if a charge of 2.5 microcoulomb is placed. Okay. So if options are given to you, it may be in the MCQ forms. If an option is given to you 2.5 microcoulomb, 2.5 coulomb, 2.5 millicoulomb and 2.5 coulomb charge. So one option that will be 2.5 microcoulomb will be the correct one. So by this way we can, solving the numericals, we can opt for a MCQ also. And 4 options if it is given to here, you can choose the correct option.